This video is about a lamp I designed. Maybe not everyone is familiar with the mathematical ideas that inspired this lamp. So in this video I will try to explain a bit about that. So first I start with the 5 Platonic solids, and they're called Platonic because Plato, you probably heard of Plato, he wrote about them already 2000 years ago, and he thought they were really special. He thought they were something from the gods, and actually he wasn't the only one, because many famous mathematicians and philosophers throughout history have been fascinated by these objects. And one of the funny things is there are only 5. The first one, it's a tetrahedron. It has 4 triangles. This one is the octahedron, 8 triangles. And the most familiar one is probably the cube, which has 6 squares. And the icosahedron has 20 triangles. And that's the 5th one is the dodecahedron. I've made a 3D print of this one. You can think of all kinds of nice variations on these solids. Like, for example, here there's a poster of the so-called uniform polyhedra. And here I made a 3D print, for example, of a compound of 5 tetrahedra. Like you can see, for example, the yellow, there are 5 tetrahedra in this, and together they form a shape which is more, a bit more like, this has the symmetry of the dodecahedron. But as I say, there can be only 5. Okay, so another thing you can do with these Platonic solids, you can subdivide each face into smaller triangles. Here you can see the triangles more clearly, and the nice thing is that you can imagine mirrors on the sides of each triangle, and each triangle is a mirror image of its neighbor, and you can generate all the triangles of the solid by using reflections. On the right you can see the dodecahedron has been projected onto a sphere using the same triangle symmetry. And I also like this one. With a sphere you can map the sphere on a plane by using what's called a stereographic projection. I've tried to illustrate it a bit here. Okay, so stereographic projection, you have you imagine a light on the North Pole and you shine it through the sphere, and you project it on the plane. So every point on the sphere corresponds to a point on the plane, and so you have a map from the plane to the sphere. Here's a stereographic projection with cubical symmetry. That's from my website. You can use a real light to make this stereographic projection. And so I made this 3D print which has a sphere, but it has a little kind of thing to attach a light. Yeah, so the lamp consists of the 3D print, a LED, and it's mounted on an aluminium tube, which through which the wires also go, and it's attached on a tin. But you can, with this tin, you can attach the lamp to a ceiling or a wall, whatever you like, with screws, and then you can just close up. I use USB cable for the power, so you can extend it with a cable to some length that you want. USB charger units. You can so you have power and light. So here's the lamp mounted on the ceiling. And this is my old version. And finally, here's one in action mounted on a wall. Well, thanks for watching, and if you need more information, there's some on the description section of the video.